Hi guys, welcome to JIK 224 E-Kuliah series. I'm Dr. Sumia Sabah and this is the 6th video covering chapters 2, which is optical activity. In this topic, we will discuss how a compound can be defined as optically active. Upon completion of this topic, you should be able to explain the relationships between optical activity and chirality. What is optical activity? When two enantiomers have identical physical properties, that means same boiling point, melting point, density and so on. Also, they have same refractive index. However, they are different in terms of how they interact with the plane polarized light. So later I will explain to you what is plane polarized light. A regular or unpolarized light vibrates in all directions. So in our day, in the light that we see every day, such as the visible light, the light can vibrate in every direction, up, down, horizontal, vertical, and so on, in every direction. But this is an example of a simple experimental setup. We have here a light source. So this is our the wave of our light, which is the wave can move in all directions. And here we have polarizing filter or polarizer. And when the light goes through a polarizer, we will have here the plane polarized light. So in this plane of polarized light, the wave only vibrate in a single plane. Okay, so plane polarized or polarized light is light that has an electric vector that oscillates in a single plane. So this is where after the light enter the polarizer, the wave of the light will move only in a single plane. And plane polarized light arises from passing ordinary light through a polarizer. So a polarimeter is an instrument that measures the interaction between a compound and plane polarized light. So this is the setup for a polarimeter. We have here a light source and usually we will use sodium lamp as the light source. And then we have here the monochromator filter. After that, this is the where we will observe the direction of a light source. So the wave will vibrate in all directions. And then the light will pass through a polarizing filter or a polarizer. So in this polarizer, we will have only one plane or one direction. So that when only one type of wave will pass through the polarizer. So initially we have the light going in all direction. So here when it passes through the polarizer, only one direction or a single direction of a light wave will pass through the polarizer. So in the plane of polarized light, we will see that only a single plane of light is observed. And then this single light or single wave of light will pass through a sample cell. This is where we put our sample, an enantiomer or whatever. And then after that, we will have the analyzing filter and also detector. From here, we will know whether there is changes in the observed delta or observed degree of deviation from the single plane here, okay, from the plane of polarized light. So the polarimeter allows polarized light to travel through a sample tube containing an organic compound, and it permits the measurement of the degree to which an organic compound rotates the plane polarized light. Since enantiomer interact with plane polarized light differently, polarimetry can be used to distinguish between enantiomers. So only a polarimeter can be used to differentiate various types of enantiomers. With archival compound, the light that exit the sample tubes remain unchanged. initially we have the light going in every direction. After the polarizer, we will have only one single plane. For an archival, when this light at the plane polarized light enters the sample tube, the plane of polarization is not changed. Okay, after that you observe that the plane of polarization is the same as the initial. Okay, so this is what happened when we put an archival compound in the sample tube. A compound that does not change the plane of polarized light is said to be optically inactive. When a plane polarized light passes through a solution containing a single chiral compound, the chiral compound causes the plane of vibration to rotate. In the case of chiral solution, when the plane of polarized light here enter the sample tube, you will see that at the end, the plane of polarization will be changed. So there is a difference in the degree of rotation between the initial here and what you observe. A compound that rotates polarized light is said to be optically active. The rotation of polarized light can be clockwise or anti-clockwise. If the rotation is clockwise, the compound is called dextrorotary. The rotation is labeled D or plus. And if the rotation is counterclockwise, the compound is called levorotary. And the rotation is labeled L or minus. Two enantiomer rotate plane polarized light to an equal extent but in opposite direction. So this is how we will differentiate between two types of enantiomer. Remember that enantiomer have a mirror image of each other. They are non-superimposable, so it's very difficult to differentiate them. The only way is through plane polarized light. So two of the enantiomer, so they are mirror image of each other. When we put the sample in a sample tube, in the end of the experiment, we will see that these two enantiomer will cause a rotation in the plane of polarized light. But the difference in them is in opposite direction. So if one compound is positive, the other compound will give a negative value. So for example, here we have 2 butanol. In enantiomer 1, we will have plus 13.5 degree rotation, while for the second enantiomer we will observe a negative 13.5 degree rotation. So the degree of the rotation is the same, but they are in opposite direction. So one is positive and another one will be negative. The direction and magnitude of rotation must be determined experimentally. So you cannot just predict or do some simple experiment other than polarimetry in order to determine the degree of rotation. So as a summary, optical activity is the ability of a compound to rotate plane of polarized light. An optically active solution contains a chiral compound, and this is the reference. And thank you for listening. If you have any question, feel free to contact me at my email address. Thank you.